Preparing for a DevOps Engineering at HashiCorp interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a reliable CI/CD pipeline for a production service? I would structure the pipeline around repeatable, automated stages: validation, unit and integration testing, security scanning, artifact creation, deployment to a temporary environment, and controlled promotion. Artifacts should be immutable and traceable to a commit. For production, I would use canary or blue-green deployment, health checks, automated rollback, and approval gates for high-risk changes. Metrics, logs, and alerts complete the feedback loop. This design keeps releases fast while making failures contained and recoverable. While answering, focus on pipeline stages, automated testing, artifact immutability, security scanning, approval controls, deployment strategies, rollback mechanisms, observability, and how the design balances delivery speed with production safety. Question 2. What is infrastructure as code, and why is Terraform valuable in DevOps? Infrastructure as code defines infrastructure through versioned, reviewable configuration rather than manual console activity. Terraform is valuable because its declarative model lets teams describe desired resources, calculate an execution plan, and apply changes consistently across providers. State allows Terraform to track managed objects, while modules promote reuse. I would protect state, review plans through pull requests, and manage credentials securely. The result is reproducible infrastructure with better auditability, collaboration, and recovery. Make sure to cover declarative configuration, version control, reviewability, repeatability, state management, provider abstraction, drift detection, plan and apply workflows, reusable modules, and the operational risks of poorly governed infrastructure changes. Question 3. How would you manage Terraform state safely in a team environment? I would store state in a secured remote backend with encryption, versioning, and locking to prevent concurrent updates. Access would follow least privilege, and state would be separated by environment or account to limit blast radius. I would keep sensitive values out of outputs where possible and never commit state to the repository. Before recovery or migration, I would back up existing state and test carefully. Regular plans also reveal drift before it becomes operationally significant. In your answer, talk about remote backends, encryption, locking, access control, versioning, workspace or account separation, sensitive outputs, state recovery, state drift, and why state should never be casually edited or committed to source control. Question 4. What would you do if Terraform plan showed unexpected resource changes? I would not approve the apply immediately. First, I would inspect the plan and classify each unexpected change as configuration drift, a provider behavior change, state corruption, or an intentional code modification. I would compare recent commits, refresh information carefully, review provider versions, and inspect the affected resource in the cloud account. If someone changed infrastructure manually, I would decide whether to codify or revert it. Only after peer review would I apply the corrected plan. Be sure to mention stopping the apply, identifying configuration or provider changes, checking state and drift, reviewing recent commits, validating imports and lifecycle rules, consulting owners, and applying only after understanding the intended impact. Question 5. Explain the difference between immutable and mutable infrastructure. Mutable infrastructure updates existing servers or resources in place, while immutable infrastructure replaces them with newly built, versioned instances. I generally prefer immutable patterns because they reduce configuration drift, make environments reproducible, and simplify rollback. Deploy the previous image rather than manually undoing changes. Mutable systems can be practical for stateful or legacy workloads, but they require stronger configuration management. The right choice depends on startup time, persistence requirements, cost, and recovery objectives. While answering, focus on how mutable systems are changed in place, immutable systems are replaced, and how each affects consistency, rollback, debugging, deployment speed, state management, cost, and suitability for different operational environments. Question 6. How would you secure secrets in a modern DevOps platform? I would centralize secrets in a system such as HashiCorp Vault, encrypt them at rest and in transit, and authenticate workloads through machine identity rather than static shared passwords. Access policies should be narrowly scoped, secrets should be short-lived and automatically rotated, and every access should be auditable. CD jobs would retrieve secrets at runtime without writing them to logs or artifacts. I would also scan repositories and images continuously for accidental exposure. Make sure to cover centralized secret management, encryption, short-lived credentials, identity-based access, rotation, audit trails, secret injection, least privilege, CD integration, and avoiding plaintext secrets in code, logs, images, or state. Question 7. How does Vault authentication differ from authorization? Authentication answers, who is this workload, while authorization answers, what may it access? In Vault, an application might authenticate through Kubernetes, cloud identity, or another trusted method and receive a token associated with policies. Those policies define permitted paths and operations. I would prefer short-lived tokens and dynamic credentials, with leases that can be renewed or revoked. This separation lets identity remain strong while access stays narrowly scoped and auditable. In your answer, distinguish proving workload identity from deciding permitted actions, then discuss authentication methods, tokens, policies, namespaces, leases, dynamic secrets, least privilege, and how an application would obtain credentials securely. Question 8. Describe how you would troubleshoot a Kubernetes deployment that keeps restarting. I would start with pod status, events, and both current and previous container logs to identify whether the issue is an application crash, failed probe, image problem, or resource limit. I would inspect environment variables, mounted secrets, dependency connectivity, and node conditions. If memory termination is likely, I would compare usage with limits and review application behavior. I would reproduce the issue in a lower environment, make one controlled change, and verify recovery. Be sure to mention pod status, events, container logs, previous logs, probes, resource limits, configuration and secrets, image issues, dependency connectivity, node health, and a methodical process that avoids changing multiple variables simultaneously. Question 9. What is the purpose of service discovery, and how would Consul support it? Service discovery lets applications locate healthy service instances without hard-coded host names or addresses. Consul supports this through service registration, health checks, DNS and API queries, and optional key-value configuration. When an instance fails its checks, consumers can stop routing traffic to it. I would define meaningful checks, secure service communication, and consider data center or namespace boundaries. This improves resilience as services scale, move, or restart in dynamic environments. Focus on dynamic service registration, health checks, DNS or API lookup, traffic routing, failure removal, multi-data center considerations, security, and how service discovery reduces hard-coded endpoints in distributed systems. Question 10. How would you implement zero-downtime deployments? I would first make the application and database changes backward compatible, because deployment availability is meaningless if versions cannot coexist. For stateless services, I would use rolling, blue-green, or canary deployment with readiness checks, connection draining, and automated rollback thresholds. Monitoring would include error rate, latency, saturation, and key business metrics. I would validate the new version with a small traffic percentage before full promotion, keeping the previous version available until confidence is high. In your answer, cover health checks, readiness versus liveness, load balancer behavior, rolling, blue-green or canary strategies, backward compatible schemas, connection draining, rollback triggers, and monitoring business as well as technical metrics. Question 11. How do you monitor reliability in a production system? I would define user-centered indicators such as request success rate, latency percentiles, throughput, and saturation, then set service-level objectives based on business expectations. Dashboards should show trends and dependencies, while alerts should be actionable and tied to symptoms or imminent risk. Distributed tracing helps locate latency across services. I would use error budgets to balance reliability and release velocity. Post-incident analysis should improve instrumentation, automation, and the underlying system. Make sure to discuss service-level indicators, objectives and agreements, availability, latency, errors, saturation, actionable alerts, dashboards, tracing, error budgets, incident response, and avoiding excessive alerts that create operational fatigue. Question 12. Tell me about a production incident you handled and what you learned. During one incident, a configuration change caused elevated errors after deployment. I helped establish the incident channel, confirmed scope through metrics, and rolled back to restore service while another engineer investigated. We communicated status and customer impact clearly rather than speculating. The root cause was an untested compatibility assumption. Afterward, we added contract tests, safer validation, and a canary gate. The main lesson was to stabilize first, preserve evidence, and turn findings into system improvements. While answering, use a concise situation action result structure, explain impact and priorities, show calm communication, distinguish mitigation from root cause correction, quantify results, and identify a durable prevention or learning outcome. Question 13. How would you design disaster recovery for a critical service? I would begin with recovery time and recovery point objectives agreed with stakeholders, then map application, data, identity, networking, and third-party dependencies. Critical data would use tested backups and, where appropriate, cross-region replication. Infrastructure should be recreatable from versioned code, not undocumented manual steps. I would automate restoration, document decision points, and run periodic failover exercises. Recovery is credible only when tests demonstrate that both the system and the team can restore service. In your answer, cover business impact analysis, recovery time and point objectives, backups, replication, regional failure, dependency mapping, restoration testing, infrastructure recreation, data consistency, runbooks, and regular recovery exercises. Question 14. What are the main risks of using containers in production? Containers improve packaging consistency but do not automatically provide security. Key risks include vulnerable base images, untrusted dependencies, privileged execution, exposed secrets, weak network controls, and resource exhaustion. I would use minimal pinned images, vulnerability scanning, signed provenance, non-root users, read-only file systems where possible, resource limits, and restrictive runtime policies. Secrets should be injected securely, not baked into images. Continuous patching and runtime monitoring address risks that build time checks miss. Be sure to mention vulnerable images, excessive privileges, weak isolation, secrets exposure, supply chain integrity, resource exhaustion, network policies, image provenance, runtime monitoring, patching, and the difference between container convenience and security. Question 15. How would you reduce cloud infrastructure costs without harming reliability? I would begin with tagged usage data and identify waste rather than cutting capacity broadly. Opportunities may include right-sizing, auto-scaling, shutting down idle non-production resources, storage lifecycle policies, and committed use discounts for stable workloads. I would preserve redundancy and performance requirements, then validate changes against service objectives. Cost controls should be automated through policies and budgets, with ownership visible. The goal is sustainable efficiency, paying for needed capacity while eliminating accidental or poorly governed consumption. Focus on usage measurement, right-sizing, auto-scaling, scheduling, storage lifecycle policies, reserved capacity, environment governance, tagging, architecture trade-offs, and validating that savings do not compromise performance, availability, or recovery requirements. Question 16. How do you manage dependencies and provider versions in Terraform? I would define explicit Terraform and provider version constraints and commit the dependency lock file so local and C runs resolve consistently. Upgrades would be deliberate. Review changelogs, test modules in an isolated environment, inspect plans, and check for state or behavior changes. Provider aliases can separate regions or accounts when needed. I would upgrade incrementally rather than combining unrelated changes. Reproducible dependencies reduce surprise drift and make infrastructure failures easier to diagnose. Make sure to cover version constraints, lock files, controlled upgrades, changelogs, isolated testing, provider aliases, module compatibility, state migrations, upgrade plans, and why reproducibility matters across developer and C environments. Question 17. What is the difference between a liveness probe and a readiness probe? A readiness probe determines whether a workload should receive traffic, while a liveness probe determines whether the process should be restarted. I would use readiness for temporary conditions such as initialization or unavailable dependencies, but keep liveness focused on whether the process is genuinely stuck. For slow-starting applications, a startup probe prevents premature restarts. Probes must be lightweight and correctly thresholded. An overly aggressive liveness check can turn a recoverable problem into an outage. In your answer, explain that readiness controls traffic while liveness determines restart behavior. Discuss startup probes, failure consequences, dependency checks, thresholds, and how poorly designed probes can create outages or restart loops. Question 18. How would you improve developer experience without weakening operational controls? I would provide paved roads rather than forcing every team to design infrastructure from scratch. That could include tested Terraform modules, service templates, automated C validation, secure defaults, clear documentation, and self-service workflows. Policy as code can enforce guardrails without requiring manual review for routine changes. I would measure lead time, deployment frequency, failure rate, and developer satisfaction, then refine the platform from feedback. Good platform engineering makes the safe path the easiest path. While answering, discuss paved roads, reusable modules, self-service workflows, documentation, templates, policy as code, automated validation, secure defaults, platform abstractions, feedback loops, and measuring both developer productivity and production outcomes. Question 19. How would you approach a disagreement with a software engineer about an operational design? I would first clarify the shared goal, constraints, and failure scenarios rather than defending a preferred tool. Then I would compare options using evidence such as load tests, incident history, operational effort, security implications, and cost. If uncertainty remained, I would propose a small experiment with measurable success criteria. I would document the decision and trade-offs, involve the appropriate owner, and support the final choice professionally. Healthy disagreement should improve the design, not slow delivery indefinitely. Be sure to mention clarifying requirements, separating people from technical issues, comparing evidence, documenting trade-offs, running experiments, considering reliability and developer impact, escalating constructively, and committing once a decision is made. Question 20. Why do you want to work as a DevOps engineer at HashiCorp? I am drawn to HashiCorp because its products address foundational problems I care about: provisioning infrastructure consistently, securing machine access, and connecting services reliably across environments. My experience with automation, cloud operations, and incident improvement aligns well with that mission. I also value products that create leverage for both developers and operators, not just one team. At HashiCorp, I would bring a practical reliability mindset, strong collaboration, and curiosity about how customers operate at scale. In your answer, connect your experience to infrastructure automation, developer workflows, cloud operations, open source or product thinking, HashiCorp principles, customer impact, and the company's focus on consistent infrastructure and security workflows. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.